I'm just sitting in my shop just thinking how handy it would be to have a bender here in the shop so I could do a lot more bend tests on the channel. Gee whiz, thousands of dollars for a freaking bender. That got me thinking, how hard is it to make our own? Now the real inspiration for this build today is from this video we did a long time ago where Jason Becker built that DIY bend tester for you all a while back. We get emails often about the file for that. I couldn't find it, so now we're going to build our own. I think I'm going to kind of design this one to be a little bit different. I've got a 20-ton hydraulic jack. This is the big red. This is what I'm going to try to build my bender around. I want it to be a little smaller, more of a tabletop size bender. And I'm not the best at Fusion 360, but I do get by when it comes down to some 2D stuff. If you don't know what a bend tester is or a bend test is, we're going to take a little sample out of each weldment or coupon that we do, usually in groove welds, to find out if they're strong enough. The three different types are going to be your root bends, your face bends, and then your side bends. Your face is where you bend the cap or the top side of your weld, and the root pass is where you bend the inside or back side of the weld. And then your side bend is when your material is so thick that you have to cut kind of a sliver out of it and then bend it sideways. And that's really going to show some really good results on a bend from root to cap is on a side bend. I've got everything kind of laid out, but I know a lot of people think a CNC plasma table is pretty much going to fix all their problems, but there's still a lot to learn when you're designing something brand new that you've never done before. Now it's one thing to go ahead and figure out how to do your CAD system, whatever you're using, and design a part. That already takes a lot of learning curve into it as well. And then you have to go through the CAM aspect, which is setting up all your settings and your plasma cutter. Right here we've got the Thermocut Extra Fire 85 HD, and this is the plasma cutter we've been running on this fast cut table for some time now. We've got some pretty good clean cuts with it. I don't know if y'all remember this, but we did two videos. So the one is how to get cleaner cuts by hand, and one is how to get cleaner cuts with a CNC table. And really the rules are still the same regardless of which one you use. We have to have good dry air coming into the machine. We need to have enough power, and we need to have the right consumables. We've got the right power, but the consumables that I was using when I ran the first time, I was wondering why it ran a little funky, and then I started pulling parts off the table and I was like, good God, this is so wrong. Taking a closer look at the consumables, while they were still good consumables, they weren't the right size nozzle. Didn't take a page out of my own book. I had 85 amp consumables when I'm running 65 amps. That leaves me a little bit of a bigger hole on that nozzle, and maybe the inches per minute was a little too quick. I did jump the gun and sent that file to our good friends over at Oshcut because I wanted to see how it would fit with a laser cut too. Before I could change any of the design stuff and try to cut it again on my table, they had it already cut and shipped back to me. Oshcut's really good about getting your DXF file, uploading it to their system. They'll tell you if there's any flaws or issues into it, and then they'll laser cut it, and they have like a 2-day turnaround time. We're going to offer both of these links down in the description below. I'm going to give you a DXF file that you can upload to their website, or you can take this DXF file that's down there and try to cut it on your own. We have a discount code with them, so it's a little bit more affordable. And let me tell you, even after changing the consumables, getting the right nozzle and everything on this, everything was set up perfectly, bumped down the inches per minute again, and we let it run one more time, and it cut way better. However, maybe my design wasn't exactly set up for plasma cutting, and some of the holes, the tab and slot design that I wanted, was not that great. The holes were a little bit still tighter than they should have been, and the holes for where we're going to be putting our rollers weren't quite a ½ an inch for a bolt to fit. So there's going to be a lot more prep with this plasma cutter than the one that Oshcut ended up sending me. If you look at this laser cut piece, it is absolutely precise. It is super clean. Everything's really square. There's obviously no dross or anything on it. Now all we have to see is, how these things all kind of get prepped and fit up. So look, even after changing those things and putting some good anti-spatter on it, re-siliconing that O-ring on the inside, new consumables, lower travel speeds, we did get better cuts. We still need to prep everything up. We've got our angle grinder with our 3M products. Cubitron 3 fiber disc was going to be coming handy for getting a lot of that mill scale off. We're going to use cut-off wheels and cut and grinds to kind of reshape the tabs and slots. So that's what we did first, was kind of clean up all the junk. So we got all the dross off of the part. We went ahead and touched up the tabs, and then of course the holes that were on there are supposed to be 1/2 inch, so we had to take our beautiful, lovely carbide burr bit, which is one of the most teeth chattering tool out there. We went ahead and made those holes big enough now for our 1/2 inch bolt that we're going to end up going through. So there's 6 of them on there, even though we're only going to be running 2 different bolts. The reason why is because of our roller and punch system. As they're coming through, we might have different thicknesses of material. So if you're doing a bend test on some 2-inch schedule 40 pipe, you might use these more closer together holes, whereas if you're bending some 3/8 plate, you might need to go down to the wider set of holes. All these things are some code standards that you'll have to try to look up and follow. You can find all that stuff there over on the American Welding program. We've got some courses that are designed specifically for codes and standards. You should go check those out if you have any more questions on the size that you're using, because it really does depend. The little punches can be different sizes depending on what code that you're trying to run to. This is going to be more of a D11 kind of standard. Like I mentioned, I ordered the Oshcut material in between the cut 1 and cut 2 of these, so there are some aspects that I didn't think of. A couple of the holes on the laser fit were just a little bit snug, so I did go back to the design and opened up a couple of those holes to fit the laser a little bit better, as well as the bottle jack that has that little handle. It wasn't clearing the side, so I went ahead and notched that out on the pattern as well. But just like a Martha Stewart cooking channel, this is what we were shooting for, and I would say that the laser fit, compared to all the prep that I had to do and all the stuff that I had to do, even getting the tabs cleaned up and trying to get the slots cleaned up, stuff still didn't fit the way I wanted. So I even just threw that cutoff wheel on there and made the harsh decision to cut off all those freaking tabs. So I went one at a time to slice off the tabs, because my plasma cut one probably won't be tabbed and slotted. Now I'll have some good layout holes that I could potentially just lay things out on and tack on, but I digress, guys. Maybe the file that I have for y'all isn't the best for plasma, but if you send it over to Oshcut, it fits like a glove. This isn't tacked together. This isn't being held together by magnets or clamps or nothing. And as far as these rollers go, you can run a couple different options. These are some really solid material. This is some S7, and we had our good friend Lucas. He went ahead and machined a few things for us. He put some through holes, put us some bearings in there so they'll spin. You don't necessarily have to go this route. You could just use some round stock, or even just some of the regular material that you use to weld with, some softer carbon steel, but you're likely going to have to replace those more often than not. With this, we should be able to last a lot longer. So shout out to Lucas. We know what we're going to be putting together. I went ahead and prepped everything, put the roll lock discs on the sander grinder dealio, and just kind of deburred things, got the mill scale off. We're going to MIG this one, tack it together, and since this one fits good, I haven't prepped it yet. We'll knock some of the mess off, but we're going to TIG weld this one and MIG weld this one. The problem is with these plasma cut slots, you might get some porosity, but let's go ahead and try to tack it all up. Now, I think if there's any good point or lesson to be learned in this video, is if you're trying to build one of something, or maybe a lot of something, it might be easier to outsource it if you don't have the best tool for it. Now, I think the plasma isn't necessarily the issue. I just need to go back to my design and make sure I don't suck. For now, the tabs are cut off, all of this. I still have the slots on here that I can kind of look at to lay things out as I tack everything. We're gonna make sure we got some generous supply of anti-spatter for the table. We've got the Everlast Thunder 255 set up right now. It's got our 75-25 mix on there. We're running our settings on the machine, 21 and 290. And then I've got, of course, our lightweight Abbey MIG gun. Tack things up. All I'm gonna do is line up my edges with these slots, and then we'll square it. Need a little tiny Mateo, Paquito Mateo. Get it close to square. Tack this guy in. As long as I know I'm on the end here, that should be good. Do it. Low, we got 2 more little tabs to tack in, and then we can put this front side on. These aren't going to be as concerning. I'm just going to try to center them over my slot and give it a tacky. Easy peasy. These little tabs here are just in here so the interior doesn't want to crumple or fold. It's just some extra bracing. But the biggest thing I wanted to do different than Jason was to make something that had a little bit of a smaller footprint for my shop, because I have a small shop. Now we can take this piece, and we should be able to just set it right over top here. The biggest point here is to make sure everything is in line and square with the bottom here, which I could probably do this, a little bit of that, to get these edges lined up. Same thing with these tops. Everything should have been pretty much square coming up, so our slots do have all of our pieces visible. The biggest issue that I think is going to happen here is when I do put some tacks, I might get some porosity because I did plasma cut those slots. But you never know until you try. I don't know how much weld we're going to actually put on this, but filling up those slots will definitely be one of the priorities that we have. Tack the slots on this other side. So there's that piece there. Now we're going to bring in the mounting plate. This is going to be the top. At least that's how I wanted it to be. Still got my slots. The goal is to kind of see those and try to center them and line up with my feet here. It's going to be my best bet to at least get close to what I wanted. But as you can see, there's a tidge of a wobble, which I imagine is from me cutting those tabs off. We are definitely going to make sure we're square before we tack. This one tack is just to kind of keep everything in place. We're going to get this pretty square right there. Looks like I need to pull just a little bit. Alright, at least we're square to the base plate, and again, checking this, got 1/2 inch from the ruler at the top here, 1/2 inch at the bottom. So that is beautiful. The last thing we need to do is tack on this top plate here. It honestly just kind of sits on there really square. It needs to go this way, so we're going to tack on that side. Those slots are helping out a lot. I would have to spend a lot more time with trying to find my measurements than what I'm doing right now, which is pretty much not doing that. No, we're gonna have to bend it back a little bit. Those two tacks are acting like a hinge. Man, that's pretty good to me. Put a couple more tacks to sure things up. That took some time, but it's tacked together. Checkpoint number 1, the bolts line up, that's good. Everything fit together square. The notch that I cut out for this so that the little jack right here has enough room to move around, that's good. I did, however, put that on backwards, so I'm gonna have to cut this whole thing from the base and then flip it. But we're not talking about that. We're moving into tacking the other one together. This is the laser fit parts. Again, these just sit pretty much right in wherever you put them. You're saving yourself already a ton of time. So we're gonna push this out of the way. I am gonna make sure I put that little notch that I had to hand cut right here. I had to hand cut that with a disc. I'm gonna leave that a little blemish on the inside, maybe fix it a little bit. But we're gonna tack everything with TIG. So the Thunder is nice enough to have a high voltage TIG. So we got our foot pedal hooked up. I'm kind of old school. I like my two-piece TIG rigs for pretty much anything and everything that I do. And this is like my go-to setup, a jumbo number 10. Two-piece TIG rigs like this on machines like that, you're gonna need a couple pieces. We have some adapters for our Linko to Tweako or whatever's you wanna call them so that they can fit into the Everlast as well as this quick connect for the gas. That way we can still have our pre and post flow that we set everything to. If you want any of those things, you're gonna have to go to Heavy Hitters website for that. Now we'll see just how much faster it is to tack this thing together. We're gonna do everything with the square just the same. I don't think we're gonna have as many issues though. I'll start by tacking with no filler. If I feel any like wiggle side to side in that slot, like this one slid this way, this one slid this way, everything's sliding up right now. And they're not with any reinforcement, so they're probably a little easier to manipulate at this point. Perfect. Well, that one already knew how to act. This goes like this. There it goes. I am not messing this up again. How did that happen? I put the notch on the wrong side of the thing. This is the thing that needs to move, and this is the notch that needs to be over here. I notched it in the wrong spot. Woo! Woo! Maybe it's entertaining for y'all to watch me make mistakes, but it is real. I definitely did make that mistake. Now, instead of notching this side, I can just break off, which I'm not stoked about either, these. So much stuff in the way. Wiggle, wiggle, wiggle. Now we simply flip it over so that that notch now will live on this side. Slide the things into their homes. It's that easy. Double check this back side in case anything needs to move. It looks good. I want to put some more confidence. Looks like she's all tacked up. Now, as a pretty amateur fabricator, I feel like I can definitely get by when my plans are in front of me and I have parts cut already and I just got to slap stuff together. A lot like this laser piece one, but whenever you have to design and build something on your own, you usually have a lot of hiccups that you have to challenge yourself to get around so that you can get what you're looking for. We were able to get it, and again, this is actually upside down. I want this to hang down because the idea here is that the bender would push your coupon down where you can come in here and grab it through this little kind of notch out right here. Everything is going to be welded fairly solid, at least the tabs and slots. I don't think I need to get too carried away trying to prevent a little bit of distortion. I would say the best part to doing both of these two builds and building two benders is seeing the benefits that is having someone else with a laser cut something and send it to you versus you trying to do it yourself. Both very achievable options. However, that one was way easier. I'm going to start by TIG welding this laser cut piece. It's nice, pretty, and prepped, so it looked delicious to weld. We were doing some slot welding here on the base plates. We're going to have a video coming out real shortly, maybe in the next couple weeks, on plug and slot welding with weld symbols and the whole 9 yards. So yeah, we want to make sure all these base plates are welded up and make sure they're sanded down just so there's no weld reinforcement to make the base plates not sit flat. And you can weld this with whatever you please. I didn't prep this part right here well enough, so it was really a nasty little weld to make. But for the second one, we've got way deeper of a slot to fill, so definitely chose the MIG welding, and hopefully the plasma cut edges aren't too big of a deal, and they really weren't. I didn't get a lick of porosity on this, so I was very pleased with it. Still removing that metal from the base plate so we sit flat, and doing that lovely drag technique that y'all love when I MIG weld with. Putting some generous amount of anti-spatter on there. Again, filling these plugs in. I'm not really worried about if these slots are filled in all the way flush or past flush, because honestly, if they're flat, they're good. I would rather do less grinding if I had to. The MIG welding was way faster, definitely set up better, and we're good to go. Now that we've got both of these pieces welded together, I MIG welded this one. Slot welds welded really nice. I didn't really even think I had to finish it a whole lot more than I did. The TIG one welded good, except for the spots where I didn't think to prep, where I flipped the plate on the other side of the unprepped side. So keep that in mind when you're doing some welding like that. The other thing we got to do next is test fit the jack. Now, this is why I hit some hiccups, that I had to do a little bit of off-camera testing here. My letters are upside down right now because my idea was the jack would be a downfire. Little did I know that the downfire for these bottle jacks, they don't work upside down. It's probably obvious to some of y'all. That was news to me. The other thing we got to do next is fit this jack portion in. And I found out that not only does the little lever piece need to be notched out, but so does the back side of that component so that it fits these jacks and it makes this head center. We did notch that back side out, and knowing that I can't shoot down, I went ahead and changed the DXF file, added the notches that help fit this in place center, and I went ahead and flipped the letters upside down. So down below, we'll have you a link to go to our Google Drive. You can download the DXF file yourself. Everything should be corrected so that it will fit this jack. There are many different jacks like these 20-ton jacks that are really similar, so it should fit quite a few. One thing that I didn't talk about was the S7 rollers that we had our good friend Lucas make. I know we said it earlier, but I did have him machine another 1.5 inch piece of S7 for that head. I had full plans on
welding it straight to the jack. Little did I know how much pain in the butt S7 would weld. I didn't even try to weld it because looking at it, it needed a lot of care in order to weld it, being that it was a really high alloy tool steel. I went ahead and took this 1.5 inch bar stock, just plain carbon steel. It was like 10 bucks at the metal supply. I cut 2 inches off of it. We went ahead and cleaned up the head of this, put a groove in it with some 3M abrasive so that we can get everything nice and lined up, and then I went ahead and TIG welded everything on, trying to do everything fairly slow as to not overheat anything. I depressurized the jack as well beforehand, and then I let everything cool off and tested it. So now the jack does in fact work, and it has the head that I need on it. This will probably work okay, being that it's just plain mild steel, but the more use that you use, it might start to deform a little bit, and you might have to cut it off and redo it if you don't have the proper head on there. But I have a piece of 1.5 inch wide by 3/8, just piece of plate that I cut out that we're gonna put in here and use as our bend test sample. Fingers crossed. This is literally, I have not tried to use this yet, so I hope it works. Whew, here we go. The true point is if it's actually going to push all the way up and through, or if I'm going to bend something. Well, I don't think it's ever going to be able to push a coupon all the way up and through because of this. Maybe if the coupon wasn't as long. I think that's about a 7-inch long coupon. Luckily, because the rollers are rolly, it does come back down, and it is nice. I did have this open so you could get your coupon out, but it's kind of nice that it doesn't just bust the surface up there. Got us a nice bend with a nice radius on it. Everything seemed to roll fine. This is meant to bend 1.5 inch, 1 inch wide. Go up to these holes, we can have 1/4 inch thickness and then a little bit thinner if you have some like schedule 42 inch. That was about 140 bucks for that piece of 1/4 inch plate. And I got that for drop prices, and I get a pretty good deal on it. For about twice the price, so close to 350 bucks, I had it just straight laser cut, sent straight to my door, 2-day turnaround from Oshcut. There's almost no cleanup, just a little bit of prep and we slapped it together. So I definitely recommend, if you're just gonna make one of these things, go to Oshcut, get that thing cut out. Again, I've had all the DXF files. I fixed all the other issues that I had on here to get this working for you all so that you can have an affordable bender. The jack here was like 150 bucks, 160 bucks. You can get some ranges there. And then of course the S7 steel in here, that honestly was not expensive. You're gonna have to find a local machinist or someone to get through that. You don't have to use S7, you can maybe use a different material. My prototypes are on the table. We should have them all solved out for you to have your own personal bending machine at your school or at your home shop so you can do your own testing for a lot more affordable than the ones you can find online. Thanks for watching, everyone. We'll see you on the next weld.